To decode instructions, as mentioned earlier, instruction has several types. For example, we may have data transfer instructions, which load or store data from the memory or I/O in other complex CPU. Some instruction types are about computation. For example, arithmetic operations, addition, subtraction, multiply, or divide. Or it can be Boolean operations to perform the logical operation on that. For example, AND, OR, execute OR. It can be bitwise operations. The bitwise operation is an operation that performs on the data in a register to shift means to move bits to the left or to the right, or rotate. The difference between shift and rotate is that for shift, it just moves data to the left, and for the rotate, and then the data on the left mode will be removed, okay, and 0 will be put in on the right bits. For rotate, the content will move data from the leftmost bit to the rightmost bit, and everything is shifted. For control instruction is to make change of program counter to control the location of the next instruction being executed. The control instruction can be unconditional jumps or branch, means next instruction we will execute the next instruction no matter what current state is. And conditional jumps or branch means it will make some comparison and then jumps based on the result of the comparison. For each instruction, there is a part of opcode and operands. In the case of Brookshire simple machine, since each instruction is 16 bits, they divide the opcode into 4 bits opcode and then 12 bits operand. So basically for 2 bytes or 16 bits, the first 4 bits is the opcode and the last 12 bits are the operand. For the operand, it can also divide it into 3 components, is 4 bits each. For the opcode, it contains the instruction type. For example, in the case of instruction value 2201, the first 4 bits, the value of first 4 bits is 2. The value 2 for the Brookshire simple machine indicates the load register instruction. This load instruction is to load the constant value inside the operand into the register. And for the bit patterns, this indicates the pattern of the operand, and this is the description of the instruction 2. It said RXY means the first operand, the first 4 bit of operand is R, next one is X, the next one is Y. So the description is this: load the register R with the bit pattern XY. This means we will load the byte or these 8 bits inside the instruction into the register, the number that indicated in these 4 bits. In this case, we have 201 mean we will load the value 01 into register 2. After we execute this instruction, register 2 will contain the value 01. Let's take a look at how it executes this instruction. If you can recall from the last time that we discussed with the example of the fetch, the instruction register contains the value 02201. Then the IR, the control unit, will put the information 01 into register 2. This based on the instruction 2201 that's in the instruction register. Let's take a look at another example. Suppose if we take a look at the next program counter, the next instruction will be on address 04 and 05. The content is 5112. So for 5112, for the Brookshire simple machine, 5 indicate an addition instruction with bit patterns. Operand pattern is RST. This means for this instruction type, we will add value from register, the number indicated by S and T, and the result will be stored in the register, the number indicated by R. This register in the number can be the same or can be different. For example, for 5112, this means we will add the value from the register 1 and register 2, and the result will be stored into register 1. So let's take a look at how this one executed. After the 5112 or the instruction at the memory location 0405 is being fetched, the program counter will be incremented by 2 to be ready for the next instruction. And then, based on this instruction, the control unit will decode and then execute as follows. First, it will bring in the content of register 1 and 2, which is in this case contain the value 0A and 01, and then send those values to the ALU. The ALU will perform the addition. Once it's completed, it will store the data back to the register 1 as indicated by the instruction to store the value of register 1 and register 2, add them together and store back to register 1. You see that this complete the cycle. So the CPU will then fetch the next instruction in the address 06, decode, and then execute the instruction based on the instruction type or opcode and operands which indicate the location, address, or value that it needs to be executed.